St. Martin's University, SBM Trailers, Coal Train. This is the ME 499 final presentation. Next slide, Taylor. Contents. We have the introduction, purpose and identity of project, team roles, design result review, design specifications, physical prototype development, physical prototype manufacturing, fabrication and assembly, physical prototype testing, project conclusion. Next slide, please. SBM Trailers, the team. On the left, John Scott Rodriguez, myself. In the center, Cole Tinsley. To the right, Taylor B. And to the far right, Ethan Myers. Next slide, please. John Scott Rodriguez, investor relations, experienced farmer. John Scott Rodriguez secured funding by leveraging his agricultural business connections, serving as a primary contact for potential sponsors, and ensuring financial resources were available for materials and prototyping. Next slide, please, Taylor. Cole Tinsley, lead researcher. Cole Tinsley focused on researching the legal and ethical codes, ensuring the trailer adhered to regulatory codes and other relevant standards. His work ensured that the design was not only functional, but also legally compliant and sustainable. Next slide, please. Taylor B., team manager. Taylor B. managed the project, coordinated tasks, set deadlines, and ensuring team members stayed on task using tools like Gantt charts to monitor progress. His leadership kept the project organized and moving forward. Next slide. Ethan Myers, lead CAD designer. Ethan Myers led the technical aspects, developing CAD models, performing load-bearing calculations, and ensuring the design complied with industry standards. His role was crucial in translating the concept into functional, manufacturable trailer design. Next slide.
So to begin, we had a full-size 53-foot highway legal in the future design that loaded hay bales up first by a robotic arm, and then that switched over to conveyor system. That became both difficult to manufacture at scale, and we also realized funding was starting to become an issue at that time. The Mark II design had the same functionality. It was the same vertical and width dimensions. It just wasn't as long, so it wouldn't have had as much of a hay capacity. And then Mark III was when we realized we were going to have even further budget issues, and Mark III being the one on the right in there, just a simplified hay picker upper mechanism, drive from a hay elevator to go onto a boat trailer, which Scotto generously provided. Mark IV was the results of doing FEA analysis, finite element analysis, onto the trailer. This resulted in some beefing up in a few places and a switch out of a few parts just for what was available at the time. And then in the Mark V trailer, which is what we ended up doing, or I would say more of a there were some fabrication things that led it to being a little off from the final design. The Mark V trailer came from Scotto finding more funding for us than we expected, and so we started adding more features onto the boat trailer platform, specifically the conversion to all hydraulics, a little bit in better intake, some more beefing up in a few places, and the hydraulic cylinder. Next slide, please.
Hi, my name is Taylor B. Um, talking about this prototype with our trailer and stuff like that, there was a bunch of parts that we had to kind of acquire through funding and stuff. So a lot of these stuffs we kind of acquired through multiple different partners and different industry uh, um, essentially partnerships that we were able to come with and come together with and be able to get this project together. Um, Eventually, it just started out with scrap iron, scrap metal, or not scrap metal, raw metal stock, which you can see on the bottom right corner. Those were all cut up, and then we welded it into the frame that you can see in the bottom left corner. And once the frame was just all assembled or finally welded up, then we were able to start throwing parts on it. And once we had parts starting to throw, we started assembling it. That's when we started to realize that there were a few issues with the, particularly with some of the fit and some of the power transmission. So we had to go back and kind of modify the design a little bit. But all in all, there was a little bit of trial and error, but most of the fabrication went fairly smoothly. It was just assembly that we just had a little bit of trial and error. It wasn't error on the part of planning, it was more on the error on the part of uh our the power was greater than what we expected of the hydraulic motor. So we just had to go back and reinforce it, uh, which we'll show on the next slide. So for this, specifically for what we're seeing here is that this was kind of some of the modifications that we had to talk about earlier. So when we got these sprockets, the sprockets had a hole that was a specific size, but the keyed shaft that we got was actually larger. So we had to go and drill it in to get extra room out and also to make room for the key in order to hold it tight. Additionally, with like our wheels were not large enough for our sprocket or for our essentially for the axle. So we had to go and make and modify that by boring those out a little bit on the drill press. And you can see some of our little ghetto, I guess you could say, rigging in the top left corner. Using some Ryobi boxes and stuff to balance our frame on, but it's kind of what we did to eventually get it done. The ideal way would have been to kind of get all the parts drilled out beforehand, though. So that's kind of one thing we learned from this. And finally, moving on to our last assembly portion of this, there was a bunch of parts that we had to go and kind of do little finishing touches on. So like the chain, we had to take some links out to kind of get the tension just right. Um, when I was talking earlier with the power delivery and it being more power than what we anticipated, we had a shaft that ended up snapping. So you can see me in the bottom right corner using a grinder to grind the part away or grind the broken metal away so I can re-weld it and fix in the field. But yeah, that was in the field right there during testing and stuff. So it was just some kind of on our feet thinking. But as far as our assembly goes, our welding, we had the frame, the rollers, and the hydraulic piston. All those, the hydraulic piston got welded on there using some of the stock, the metal stock that we had on the extra. For the grinding, we had to kind of use the grinder to kind of get some of the final fit, and then yeah, that's everything.
Right. I'll be talking about some of the prototype testing that we did. It took 2 days. We had some workshopping to do in between. Taylor did a great job with that. Taylor, go ahead and play that video and I'll describe what happened. Okay. Basically, what we ended up having happen was when we initially tried to spin it, we had it going the wrong direction. So we ended up bringing it off a little bit. We had a lot more power in that motor, like Taylor said, than we expected. It ended up causing that shear. You see in the top right corner where our axle is kind of comes to a point where it's sheared off from the motor. We needed to jury rig something. We needed to get some welds in so that we could try again, uh, try to run it at a slower speed, get something going to show project completion. We ended up finishing with it the next day. Taylor, go ahead and go to the next slide. All right. In the top left, you'll see kind of a shaded but good picture of the welds that Taylor completed between days 1 and 2. And in the top right, we have the video of it finally running. Taylor, go ahead and play that video. Okay. Yeah, as you can see, we got it running. We managed to fix the connection point and everything kind of worked how we wanted it to. There was another function, obviously, that hydraulic cylinder that raises and lowers. There's an example of that on the next slide. Taylor, go ahead.
Yeah.
Yeah, it was a little choppy, but that was a good video. It showed our hydraulic piston and its ability to raise our slide up. Uh, Chain ran properly, and the roller slid the bale behind it back pretty much exactly how we wanted everything to function. That was really, we were really happy with our results in the day 2 of testing. Taylor, go ahead and go to the next slide. All right. Simple project conclusions. Overall success. We got most of what we set out to do done. Uh, really happy with the overall testing and the product that we kind of ended up working with. Lessons learned, time management, some things, especially in the design initially, we didn't quite get together on, and we figured out how we needed to do that. Resource management, uh, Taylor and Ethan mentioned it before, funding kind of fluctuated up and down, and we kind of ended up with what we could supply for. And teamwork overall, I think we did a great job. And congratulations, class 2025. Obviously, this is senior design. We're all graduating more or less, so congratulations. Go ahead and go to Ethan.
So I've been asked to do a little bit of an appendix here and add some details for future watchers. So on the top left, at that moment, we weren't sure if the hydraulic cylinder would just like tweak the frame because it was uh, such a powerful cylinder that was supplied to us by Tractor Supply. It was within our spec of stroke, but we didn't it just due to the nature of hydraulics, we're just like going to be taking the full force of Scotto's tractor on it, and we were hoping it was going to work, and the math in the end did prove out, and it flexed less than we thought it would. So good job on that. On the bottom left, I am pounding in some keys into keyways because unfortunately our um, sprockets, they were advertised as coming with keyways, and when they actually came, not only did they not have keyways, they didn't even have concentric holes. They just had cast holes in there that were neither straight, they were not straight or circular in any form or fashion. So it required some hand manufacturing with a Dremel. And then to make sure it didn't move around, we could have gone with E-clips, or we just decided to end up going with lightly tapping the keys into place. Temperature might have had something to do with that on the farm that day. It was not the same as when they were manufactured out in a cold garage at night. Um, but in the end, it worked out, and they held up. Didn't crack either. And then on the right, you can see our chain guide. That was not the planned design. We had some extra sheet metal that we decided we didn't need to make like kind of a ramp for the hay bales to fall down in a controlled manner, and instead we just made that ramp with the rollers artificially. So Taylor fabricated up the chain guide without a groove in it. There is a groove that hay elevator chain guides typically have a groove in them for the chain to follow. Instead, we just relied on the tension of the chain, and then we just went with kind of a low resistance design on the chain guide, which Taylor manufactured out of the spare sheet metal we had. Okay, so to add a little bit further context, if you guys look on the bottom left corner, you'll see the hydraulic cylinder. That was mounted on by cutting up a 2x1 piece of extrusion and just welding it lengthwise to get as much surface area as possible, and then popping a hole through it and just poking the given clevis pin. It was a brass clevis pin on the bottom. And then on the front, we assembled the leftmost a big piece of steel right there, and then we put the cylinder on, had everything put together, and then we also knew we wanted a 3 inches of clearance on the smaller adapter, and we knew the distance to the top of the intake. So we just made another piece of steel. We kind of just put it all together, and then once we had it all together, we visually gauged and like put it in place where the second cylinder needed to go, and then marked that out with the Sharpie. So we had just the right fit, even with all the tweaks and stuff, thus making the hydraulic cylinder work very smoothly. And then I also want to add, it's kind of hard to see, but in the top left corner, the fix we made after we broke the shaft from turning too hard, looks like we're going to go there right now. That was done, well, the motor, it had a threaded shaft, and then also had a keyway on the top, and a key that we thought was stuck in there. After much effort, we got that key out, even though we were still going to go with the threaded way, and then the bolt broke. So we decided the best thing we could do was use a shaft collar with a set screw in it, the set screw that just happened to fit inside of the keyway. So we tightened that down, and then we just welded the sheared off piece of shaft to an intermediary, and then we welded that intermediary to the shaft collar, thus preserving the motor for future use, and making the setup strong enough to take the full torque of the hydraulic motor. We are in discussion about if what the purpose of that threading was, because it seems that it would not be strong enough with a simple, like a standard bolt, to take the full force of a hydraulic motor. But an interesting note about that hydraulic motor specifically is that it's the same displacement but different horsepower, so you can get a different speed. And I picked a middle of the road one, so maybe it would have worked if we picked a less torquey motor that spin faster. Next slide, please. It appears that was the end of the slideshow. Thank everyone for watching. Go class of 2025.